This meeting is being recorded.
This is a record.
Okay. Let's see. So yeah, I'll officially get started here. All of your stuff should be graded that you all have submitted for this, whatever the last two assignments are. The most recent one with the RAG News thing, pretty much everybody got full credit. If you didn't, there was just something super minor wrong. So I gave you 0 out of 1,000,000, obviously. But I told you what the minor thing was and told you to just fix it and send it to me again, and I'll give you back 1,000,000 points. So yeah. But yours is not? Then probably I didn't press the release to student button, and so I will do that today. Yeah. But yeah, there are no like major problems from anybody that I saw. Two things. One of them that we'll be going over today is like, I don't know, people's different prompts, system user prompts things were all, as one of the big things that I was looking at. They were all over the board in terms of how good I thought they might be. That's okay. There was no sort of like, and even at this point, we really haven't talked about ways to evaluate like how good something is other than just getting your like vague vibes check of what's going on. But your next homework, you'll have like some concrete numbers of goodness that you'll have to meet here. And we'll talk about, I don't know, a little bit more about these strategies of prompt engineering, and you'll have to revisit some of those prompts that you wrote and hopefully make them better. The other thing is this minor/major thing is that there's a lot of extra files that people are including in the repositories in different spots. And in some sense, it's a minor thing because you have all the important stuff for me to look at. But in some sense, it's like a major thing in that if somebody else is looking at this repository and it looks disorganized and ugly, that'll be their first impression of you, that you're disorganized and ugly. And that's probably not what you want to have as being first impressions. So it's just good to be in habits of making repositories a little bit contain exactly what they need and nothing more, nothing less. That was one of the things that some people I made you fix and resubmit, but overall I was not super picky on that, at least by my standards. I don't know. Questions about anything we've done so far? Homework or anything? Okay. Last time on Monday, we started talking about the LLM evaluation stuff, and basically did a big meandering tour through different benchmark stuff. Didn't cover like half the different links that I have in this repository over here, and I'm never going to cover those things. Again, like the format-ish of this class, one of the ways to be successful, take away good things from this class, is that I have these things here because they're interesting to me, things that helped me understand things, and I would recommend that you all spend just like an hour or two going through some of these various links. But that's not something that's ever going to be graded, and so I understand if you have other pressing concerns where you're actually being evaluated on things, that you're prioritizing those things. But again, one of the sort of bigger picture goals of this class is that I'm structuring it sort of like a typical computer science graduate class where the professor, instructor is just talking about things that are interesting to them. And the way that you do well benefit from those classes is by not just doing what's required, but spending lots of time exploring those different things. And so part of this experience for you all is seeing if this like less structured environment is good, productive for you all, then maybe like graduate school might be something that is helpful for you, a place where you will thrive. But if this lack of structure is a stumbling block for you, then graduate school is definitely not something that you would want to be doing, because very little structure in graduate school. So yeah, lots of various things that sort of talked about, sort of skipped over, and all of this stuff. I will, lots of things actually that I'll come back to revisiting at different points. I won't even highlight what things I'll come back to at different points. Maybe the one thing that I will highlight, though, is that there's so many of these benchmarks, and nobody keeps up with them all. It's impossible to keep up with them all. Everybody has just maybe one or two benchmarks that they sort of like, and that's the only things that they sort of track. Again, one of the reasons why these benchmarks, nobody really keeps up with them all, is because a lot of these benchmarks are actually really, really bad. And I talked a little bit about last time about how OpenAI probably accidentally, but also accidentally on purpose, cheated on this Codeforces benchmark. And this particular link right here talks about like actually being able to prove that they were overfitting on the Codeforces benchmark, and something that like it's good for OpenAI to report good numbers on things, makes their investors happy, and they don't really talk about like the details of how they do things, and so it's impossible for us to really know like whether their numbers are as good as they say they are. And that's true for not just OpenAI, I'm not just picking on them, but like every one of these large language models, whether it's made by Google or OpenAI or Anthropic or Facebook, one of these open source sort of models, they all suffer from these problems. So benchmarks, they definitely lie. That said, we are going to use benchmarks today in our homework, and we'll be going over today how to do that, how to create a simple benchmark that is designed for our RAG problem here, and the one that you just completed doing the political news, and that will be your next homework assignment. The due date, again, I mean, all the due dates sort of nominal in this class, but this is a super nominal due date of next Sunday. I think it's realistic to do all this in just a couple days, but it is more than maybe the previous assignments. So it's, I don't know, my solution here is like 80 lines of code total, but it's like there's no structure at all, essentially, that I'm giving you. I'm just telling you to go out and do this stuff. So I will not be offended if this nominal deadline is not met by anybody. But that is the nominal deadline, next Sunday. Big picture questions before we get started in details of things?
We're going to need the meta HTML stuff working.
Good question. The question is, do you need the meta HTML stuff working? And the answer is no. Let's see, in just a minute over here, I will be going over to my solutions branch of the RAG News project. And so in a minute, it'll be useful for you to have that pulled up. But everybody who had a solution submitted is in a perfect place to continue on to this next task. All you need is something where that RAG function is able to spit out some sort of answer. Good question. Okay, I'm going to talk a little bit about the structure of our benchmark suite, and then we will talk about the details of the programming assignment. So if you click on this link right here, you'll go to this repository that I created last week about our, I call it the Hairy Trumpet repository, which is for generating what are called close-style benchmarks. These close-style benchmarks are, they've been sort of the state-of-the-art standard way of making benchmarks since the mid-2010s, like 2015-ish. The first model, if you've heard of it, that really made these popular was the BERT models, one of the earliest of the transformer models. But a lot of the benchmarks, not all of them, but a lot of the benchmarks that we talked about last time are these closed-style benchmarks. One of the main things that they're not good for is like coding evaluations, but one of the main things that they are good for is testing knowledge about things. And so they work really well with RAG systems, and so that's what we're using them for. So to see what exactly a closed benchmark is, we will, and it's closed with a Z, not closed with an S, closed with a Z, we will see two examples here. So this first example comes from fungus knowledge. Basically, I downloaded a Wikipedia article, and this is the Wikipedia article on the fungus called hairy trumpet. There's a picture of a hairy trumpet over here. And then I did what's called masking that keyword of hairy trumpet, which means that I took out that word. So here, hairy trumpet used to be this thing right here, the common name for Panis fasciatus. But I've created a data point by taking that word out and putting in this like special mask phrase right here. And then the goal of our model is that it's going to read this sentence in, see that it contains this mask 0 right here, and tell me that mask 0 should be equal to hairy trumpet. If it's able to do that, then that gives us a good sense that like the model actually really knows what a hairy trumpet common name fungus is and how that relates to, say, the Latin name or the genus and all these other different fancy terms in here. So that's one example, not our domain. The second example here from our domain, also a sentence right here from Wikipedia. In this case, it was said Harris is the Democratic presidential nominee and Trump is the Republican nominee, but I've masked out both of those two words, and the model should be able to identify that this mask 0 should be equal to Harris and that the mask 1 is equal to Trump. And if it can do that well, then like that gives us some confidence that our model actually knows something about what's going on in the election right now. And if it cannot do this, then that gives me very little confidence in our model for the election. So basically, we're going to have, I think the final data set is 300 of these sentences that are something like this, that contain all the different nominees, so not just Trump and Harris, but like from the minor parties as well, with different things about them, and the model has to predict basically which person those sentences are about. And if it can do that well, then it probably knows what's going on with the election. If it can't do that well, then it doesn't necessarily mean it doesn't know what's going on in the election, but it gives us a clue that it might not. Are there any questions at a high level, like how these sorts of examples are generated? Like, or what the meaning, what the task is here? Does it mostly make sense to people? Some head nods? Yeah, question?
I know like sometimes LLM will like output some random like content behind like the response, like how do you?
Yeah, that's a good question. So the question is that like maybe the LLM knows that the common name for Panis fasciatus is hairy trumpet, but it outputs like a whole bunch of stuff in order to do that. It might say the right word somewhere in there somewhere, but it's got like paragraphs and paragraphs of stupid explanation about other stuff that it doesn't need. So that'll be one of the things that we'll talk about, like how to fix that today, or some ways of getting around that. But yeah, that's going to that's one of the main reasons why this is not like if the model does well on this task, that's a good signal that it knows the thing. But if the model does not do well on this task, it doesn't guarantee it doesn't know the knowledge, because it might just not know how to do the formatting stuff or something like that. So yeah, we'll start talking about that sort of question. How do you get the formatting right today? That'll be an important part of getting your accuracy scores on this task high. Next week, we'll talk about some fancier things than we'll do today. But good question. Any other high level-ish sort of questions? No? Okay. So the actual format of this data, here, this structure of the data, that's what's called a JSON-L file, commonly called just a JSON file, but slightly different, a JSON-L file. The L here stands for lines. And the idea is that every data point in our different files contain a single JSON object, usually a dictionary, but sometimes a list, usually a dictionary. And every line corresponds to one data point or one JSON object. So for the example that I had above, this is what the data point looks like. That the dictionary has two keys inside of it: masked text and masks. The masked text is the thing that we had up above, and includes these like special tokens, mask 0 in square brackets, and then the masks is like what's actually supposed to be substituted in there. There is A little bit of minor special formatting going on in here, like with adding some underscores and things in special cases. But in general, the token, like this thing right here, is basically just whatever this was, copy and pasted inside of it. If there's more than one mask in the text, then the masks field down here will have multiple values. So mask 0 corresponding to Harris, and then up here mask 1 corresponding to Trump. And so we'll have to write a system that passes this over to the LLM somehow, or passes the mask text part to the LLM, and then compares the output of the LLM to the masks. If this was like a classification task, this here is like the ground truth label, and this up here is like the input data. So like the X and the Y. Let's see, it looks like the screen is slowly getting more and more fuzzy. I taped it again today, but I don't know that it's good enough tape. So if it gets fuzzy enough that you guys can't see at some point, let me know, or we can try to fix that. Maybe I'll do one more size up to make it easier to see now. Any questions about the format of the data? Yeah.
So in the case for the second example, when it's mask 0 and mask 1, do you just list them?
Yeah, exactly. So the number over here in the mask token over here, this is the order, the index into the list down here. That is the word that should be substituted in here. I don't actually have an explicit example in the README file here, but so one of the sort of pre-processing things that happens is all of the different variations of the word, like Harris, for example, Kamala Harris, or Harris, Kamala, or all of those things will get lumped together as the same token here. So this here might have actually said Kamala Harris is the Democratic blah, blah, blah. But we don't have to predict what the grammar way that it was formatted. All we have to predict, all those things get lumped together as Harris. So all we have to do is predict whether it was Harris or Trump without predicting, say, was the first name also president? Or was the title Vice President Harris? Was that also president or not? We don't have to predict that stuff. That's taken care of in the generation of the data set. There are some notes down here about generating the data sets, but you won't have to follow this. This is more just in general, anytime I am creating a project for myself, I want to have some sort of documentation so that I can know what to expect coming back to it a year from now or a couple months from now. And so you're welcome to look at this. You're welcome to try generating your own data sets, but you don't have to do anything with this section down here. The important thing that you'll want to reference is just this structure of the data section here. Okay, any questions about the data before we go into what to actually do for the assignments or the code? Cool. So coming back over here, what to do, the details of the assignment. So you're going to be taking the RAG News assignment that you started with and doing all this stuff down here. I'm going to start walking through these commands or all of these steps in the terminal. You're welcome and encouraged to follow along with me, do your best that you can, and then we will start actually implementing some of this stuff in a minute related to the data set. But the first stuff is more just administrative stuff. But coming over here to the terminal, again, I have two terminal windows open, top and bottom. I usually like to code with two terminal windows. And I have my ragnews.py over here. And yeah, this is my solution branch that I'm currently in. You all are probably in a master branch. The first instruction here is that it wants you to create a new branch here that's going to contain all of your evaluation code. This is not a strictly necessary thing, but it's a good habit to be into, just to be making lots of branches in Git. Git makes it relatively easy to create new branches compared to other version control things. That's really the reason why Git became very popular, is this ability to branch. And so it's a good habit just to be taking advantage of that. So in a lot of the assignments in this class and my classes in general, I try to get you all to practice some of those skills. So git checkout -b, I think I called it evaluate. The name's not super important though, but checkout -b changes me into this evaluation branch and creates it. The checkout changes branches, the -b says create it if it doesn't exist. So I'm now on this evaluation branch, and again, branches are not at the terminal session level, they are at the file system level. So both of my sessions automatically in the evaluation branch with this one command up here. And the next thing that the instructions have you do is create a new folder, rag news, and move your ragnews.py file that you were working with last time into this rag news folder. We're going to be creating, basically we're going to be structuring this like a typical Python library, something that you might pip install. And so again, I'm just trying to get you in some good habits for, so that other people think you are Pythonic, and if other people think that about you, they're more likely to want to use your code, more likely to want to hire you to do Python things, and so on. So if you are doing something in Python that can possibly be construed as a library in some way, this is 100% standard the way you have to structure your code, or people will think you're weird. And the name of your repository, whatever it is, you should also have a folder with that exact same name inside of it, and that is the folder that contains your actual Python code. In this case, maybe before I move it, down here, I'm just going to open up Python and do an import rag news down here. I guess I have to also load up my environment. Whoops, that's not the export that I wanted. That's the export that I wanted. Export cat.env in order to get the environment set up, get that key over here. And now if I do Python 3 down here, import rag news. Then in Python 3, when you do the import rag news, it first searches to see if there is a Python file that has that same name, so ragnews.py, import rag news like this, and that works. If there is no Python file, so if I move this ragnews.py, it's going to look at the folder over here that contains that exact same name, and inside that folder, it's going to look for a file called _init or _init.py. And so I'm going to move this, in particular, git move ragnews.py into ragnews/init.py like this. And now that I've done that, there is no ragnews.py over here, but Python 3 still allows me to import ragnews like this, and is happy. So if you're like a directory and you're importing a directory, Python always imports the whatever this _init.py is. There's a lot of things that are super annoying to me about Python's import system. It's basically designed to be compatible between Windows and Unix with a bunch of like ignoring all the weird file system differences between them. Other languages don't care about those differences, but Python does, trying to make it easier for beginner users to do things, but it makes it harder for, I guess, library authors to keep track of things. But so that's why Python does things the way they are. You never actually load a specific file. Instead, you load, in Python, this is called a module. Ragnews is a module that you're importing, and that module can be located in many places, but the first thing is that it's either a Python file with that name, or it's a folder with that name that contains the init file inside of it. So that's why I've moved that in here. And then the last step of getting us set up is that I need to create a new file, vim, it'll be ragnews/evaluate.py. So evaluate.py is going to, so because I have multiple Python files, the structure is that they should always be contained inside of the same folder. Again, with that folder's name being the same name as your repository name or project name. And I'm having a separate Python file because this is going to load in our original rag function and do some stuff with it. So up there, And then over here, import rag news like this. Maybe I'll add a quick doc string. This file is for evaluating the quality of our rag system using the hairy Trumpet tool / dataset. So this imports rag news like this. And just in order to check that everything is working, Python 3, yeah, I'll load it this way, rag news / evaluate.py. That's one way that you can load it. The -i over here means that you don't have to explicitly import it. Or if I do Python 3 like this, then I can do import rag news.evaluate like that. And it, either way gives me access to the code here. If you are getting some sort of error about the code not being able to import on Unix machines, for whatever reason, Python, like the current folder, is not a place where the Python interpreter looks. Python, in order to add more folders to where the Python interpreter looks, it's this Python path environment variable. So I have to do export Python path equals dot to add the current folder to where Python looks for things. And if you do that, then you should be able to import things fine. It's just, again, standard structure for working with multiple files in Python. It's not the only way that it's possible to structure things, but if you structure things differently, then other people will not understand what you're doing, and they will think you are weird. Any questions about this structure before going on? Yeah. Thanks.
The only thing in your rag news folder should be the index.py and evaluate.
Yeah, so I'll have two things in my rag news folder. There are no Python files at the top level here. Two things in the rag news folder that are Python things or Python files, evaluate.py and this init.py. This PyCache thing, the Python 3 program automatically generates these for complicated technical reasons that make Python go faster. So this will also likely be in there depending on your setup, but these are the only two things that are important. Maybe as an aside, this is an important line to put in the git ignore file because PyCache, it actually has security implications. If you accidentally upload that, it contains potentially things that are like arbitrary locations on your computer's memory. And so it could contain, for example, like passwords inside of it. It's also just, it's not applicable to anybody else's machine, only your own machine. So nobody else can use it. So it's the kind of thing that's ugly to see in somebody else's Git repository. Good question. Any other questions? Yes. Question is, what should be in this init.py file? And the answer is that this is exactly my my ragnews.py file. I just renamed it. So the important thing that we're going to be using here in a little bit is this rag function in order to take the data set that we're working with and pass it over to this function. Here's my implementation of that function. So it does have the implementation in here. It should work. And we'll use that, like basically we're writing code that's going to evaluate this function for us. Like we're writing test cases in some sense for this code right here. Yeah, Ron.
So if we just add PyCache to our git ignore, is that going to stop all instances of PyCache, or do you have to like specify each one?
This is a good question. So in general, when you specify things inside of git ignore over here, if you don't have what's called a qualified path is something that starts, maybe I'll start here. So git ignore supports hash for comments. So this is a comment, this is a comment. All of the above patterns, they look like regular expressions. They're not regular expressions. So I'll just call them patterns. All of the above patterns are unqualified paths. Unqualified paths. A qualified path is one that starts with a slash or dot slash. And if you have a qualified path, then it's actually going to like reference that particular path in your git ignore. And so if I were to do something like /_ pi cache right here, this would match the pi cache in the current folder, but not pi caches in other folders. But if you have an unqualified path, then it's going to match this wherever it happens to appear. These stars, I mentioned they're not regular expressions. They're closely related to the Unix glob, but unfortunately they are actually different than the Unix glob for weird technical reasons. So everything's for weird technical reasons, yes. But it's like very, very close to the Unix glob. So this matches star.db, any file that starts with .db. Or PyCache, it has to exactly be PyCache and can't be anything else. Good questions. Okay, if more, I don't know, background-ish sort of questions come up as we're going, then feel free to jump in and ask them, but otherwise I'll go into the actual coding stuff next. Maybe one thing too that I didn't mention is that you will need actual access to this Hairy Trumpet repository. If you have a repository inside of a repository, you want to create a submodule in Git. This is the incantation here that will get you access to that. But I already have access. I already have that in here, so I'm not going to actually run that command. But if you run that command, it'll just create this folder inside of here, and then you'll have access to all the stuff in that folder, in that submodule, or in that repository. Okay, so that's going up everything through the step 4 right here. And now inside of this evaluate.py, we're going to create this new class called rag classifier. So I have it. So I'm loading up Vim on my not init.py. That's not what I want. I want to open up the evaluate.py file, this new file that we're creating, and we're going to create this class rag evaluator like this. And I'll just pass. In general, in Python, you always have to, this is called a block right here. Anything that's indented is a new block, and blocks cannot be empty in Python. So if you don't want to have anything, you have to put this word paths. And just coming down here, checking that that is going to work. Confusing thing about Python is re-importing a file after you have made some changes to it does not do anything. So this has an error up here. It should crash, but I can still import this file. So as you are making changes to Python, or as I am making changes, I will continue exiting Python and then re-entering Python. And I like this -i, where it automatically loads all this stuff for me, so I don't have to retype in import, and so I'll do that. And it should be, I took out the crash, that's why I didn't crash. There. Now this should give me that error message, ASD not defined. So that's just verification that I am in fact loading the right file and have a environment where I can type stuff in and it will work. Okay. Any questions so far? We're all good? So this rag evaluator class, it's going to be following this scikit-learn interface for libraries, for classifiers, for classification systems. And scikit-learn, we don't have to import that model. We don't have to do anything with this module directly. But it's a very popular machine learning library. You've probably heard of it or maybe used it. And the standard way when you're creating things that are going to be make it bigger again because things look like they're fuzzier. The standard thing to do whenever you're making anything that looks like it might possibly be a classifier is to follow this interface over here. The interface is very simple for us, for our simple purpose. It just has a single function predict inside of it. It takes self and the data point like this. The self, again, referring to the class that we're currently in. So if I create any member variables inside of this class, I'll have access to themselves, and this X over here is the actual data point right here. And then my goal, what I want to be able to do is, so I'll write out my doc string over here, create some sort of basic doc test for myself, is if I do something like model equals rag evaluator, then I want to be able to do something like model dot predict on a string that's something like mask 0 is the Democratic nominee, and have an output of what mask 0 is supposed to be. So something like HARIS, like that. That the output of this predict function should be like whatever the text is that we think these masks are supposed to be. And again, like this is in general my way of coding for everything. Make this bigger one more time. Hopefully everything will still fit on the screen, but so things aren't as fuzzy. And I always start thinking before I write any code, I think about what is the output of that code, like what should it look like? And one more little test case for myself here, predict mask 0 and mask 1 are, we'll do the, mask 0 is the Democratic nominee and mask 1 is the Republican nominee, something like this. And then I have to think about, okay, well, if I'm not just predicting one thing, but I'm predicting two things, then I can't do that with just one string. I'll have to have a list of strings. Harris and Trump are the correct answers down here. And so I should modify my original test case up here. Even if there's only one thing like this, then it should probably have a list with a single entry in it so that the types of everything line up. Maybe a good other test case to be considering here of what I want my code to eventually do is that if there are no like of these mask tokens, there is no mask token here, then it should give me an empty list. Like the data set doesn't have anything like that inside of it, so this is not a maybe in some sense as important of a test case, but just a way that I should be thinking about my code, making sure that I'm covering my basis of all the different types of test cases that can happen. And thinking about these edge cases is likely to actually help me simplify the code that I end up writing. But again, the first purpose of these doc tests is to explain not to the computer what your program is doing, but to other human beings like yourselves what this code is supposed to do. So are there any questions that you all have based on these doc tests, what this code is supposed to do? We're good? Okay. So now I have to figure out how can I use my RAG system or these LLMs in order to be able to answer these tasks. One of the things that you might think about doing, you might think about calling the run LLM, the ragnews.runLLM function directly, and we could evaluate that function directly if we wanted to. Again, here the ragnews dot over here. This is the module that the function over here is contained inside of. In this case, it's not contained in ragnews.py anymore. It's contained in the ragnews/dunder-init file. But we don't want to actually evaluate run LLM. We want to evaluate our RAG system. So we will call the ragnews.rag function. So ragnews.rag, and the first thing that I want to do here, I guess I need to, let's open up my ragnews.rag function. So I just opened it up in another tab over here, and def rag. I want to make sure that I remember what the actual parameters here that I need to pass in. I need my text that I'm doing a query about, and then the database that I'm going to be searching. So I'll need to create this database. I've forgotten how to create a database, so I'll search in this code for an example where I created this database, something like db equals something like this. So I'll copy that over here. db equals article db. This database now is it's in a different scope. It's not local to this file. It's in the ragnews module. So I need to do ragnews.articledb. And then I need some sort of text prompt equals hello world, and pass those in over here, text prompt and db. Again, one of the things that I'm trying to illustrate here is that is like a general good development practice about how I go writing every sort of function that I work with, not just this sort of LLM function, but every sort of function. And these LLM functions are particularly complicated, and so having good habits will make writing them more easy. And the good habit that I'm trying to illustrate right here is that I'm not trying to actually solve this problem all at once. I'm trying to just get some sort of framework down about how I'm going to solve this problem and make sure that this code does what I expect it to do before going on to actually trying to solve the problem. So again, every time I'm coding, I make very small changes to the code, just like 2 or 3 lines at a time. Here I've made 3 actual code changes, code lines, and I make sure to actually run those, make sure they're doing what I think they should be doing before I go on to doing something else. So let's reload that evaluate.py. It's good we have no syntax errors. It loaded just fine. And I called this class up here rag evaluator. So I'll do something like model equals rag evaluator, and then I can do that model.predict, and I need to pass in some sort of text over here. We'll just do this first test case right there and see what happens. And we don't get any errors, so we're not solving the problem yet, but we're making some sort of progress over here. Maybe one thing that I will do is now add the output text of my rag function over here, output, and then return output like that. So we can see what the actual output of these functions are. Again, every time I make a change like this, I have to save the file up here, come down, re-quit out of Python, reload Python, and rerun all of these lines down here. That's 2 lines that I have to rerun. I press the up arrow twice to do that, and it's able to rerun the thing. And this is what my rag news thing is telling me. Any questions on anything I've done so far? Okay, then let's get into some of the actual interesting things now about what we have to do with these prompts to make the stuff actually work. The first thing that I have to do is actually get my text that I'm passing in over here into my prompt over here. I'll use a Python multi-line string to make this a little bit easier. And I'll do something like, so providing some sort of explanation. This is a fancier question that is based on standard close style benchmarks. I'm going to provide you a sentence, and you need to, I'm going to provide you a sentence, and that sentence will have a masked token inside of it with or outside of it that will look like mask 0 or mask 1 or mask 2 and so on. And your job is to tell me what the value of that masked token was. And then down here, I'll say the masked sentence is, and put in here whatever the input text is up here. So in my function right here, I called the X being the name of the input text. Maybe I'll do something a little bit more meaningful now of masked underscore text like that. And down here, I'm going to change this to be a format string, an F string right here on my text prompt, so that inside of these curly braces, I can do masked text like that, and that is being passed over to the input into the string. And so there's a first pass of writing a prompt that's going to try to solve this task. I'm explaining what the task is up here, but and we'll see, it's probably not going to work very well. But we'll see exactly what the output is down here, and hopefully it does something closely related to what we want. So rerun this, run that, I predict. here's the output. However, since there's no mask token in the provided sentence, okay, that makes sense. The provided sentence I have here is there's no mask token here. So maybe I should try a new sentence from one of the other doc tests up here, like this one right here. So I'll copy that, come down here, up a level, delete all of that, put that in here, and see what happens. And here now we get blah, 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 blah. Mask 0 is likely to be Jackson. I have no idea why, but that's what it thinks it is. So this is bad in two ways. Bad in the first way is it's not following the right format. It's not giving us just like a single word or just a list of those mask tokens. And the second way is that there's a whole, like it's just the wrong answer. Say it again?
That's who it is. It doesn't say who Jackson is.
Yeah. Well, let's see. Jackson could be a dark horse candidate who ends up securing the nomination. I've never heard that phrase. Is that a thing that people talk about? Dark horse candidates?
Yeah.
Okay.
It doesn't say what they're doing.
Yeah. So it's a really bad answer. Yeah. So we need to come up with better prompting strategies to improve this evaluation system. And so I guess like the first takeaway of something here is that like no matter what, like I might have a perfect RAG system right now that's able to do everything perfectly, but if my prompt for the system that's evaluating the RAG system is bad, then, or my framework for evaluating the RAG system is bad, then there's no way that like I will know that. So one reason why you could have bad results, and this should be, yeah, we'll put it down here. Just one. So reasons why you could have bad results. Reasons why bad results is the code in this function is bad, especially the prompt. Or the other is that just like the RAG function itself could actually be bad. The RAG function itself could be bad. And at this point, we don't know what the problem is. Actually, I mean, it's probably this thing up here. There's a lot more stuff we can do, but so we can't identify whether the RAG function yet is good or bad. Any questions about what we're doing so far? Mostly straightforward, makes sense? Okay, so one of the first tips from that, I gave you a link a little while ago about prompt engineering from OpenAI's guide to prompt engineering. One of the first tips they provide is that you need to be very explicit on the size of your output, what we want the model to output. And we don't really tell anything about the size of what the model should output yet. So I'm gonna add a couple sentences up here that are like the size of your output should just be a single word for each mask. You should not provide any explanation or other extraneous words. So this is one standard like prompt engineering thing to do. Always provide the size, some description of the format of what you expect to have output. Maybe I'll also say if there are multiple mask tokens, provide each token separately with a white space in between. So some description of the format up here. Another good strategy, another one of their tips, is to provide some examples of what those input-output pairs. And we already have some examples of what we're expecting up here in these that I've written in these doc tests up here. So I'm going to start by copying these doc tests down here and reformatting them a little bit. So it looks something like input, mask is the Democratic nominee, output, Harris. Input, mask is the Democratic nominee, and mask 1 is the Republican nominee. And then output, Harris, space, Trump. And then now we will do input colon, whatever our actual text was, masked text, and then output colon. And there's nothing after this output colon, so it will, hopefully the idea here is that it will see, oh, when I got an input before, it looks something like this. And maybe I should get rid of that extraneous quotation mark. And this is what the output was supposed to look like, just a single word right here. Input of all of this, then the output, these two separate words. And then the input, whatever the person actually passed in, and then the output down here. So two strategies, what here being very explicit about like what providing a description of what the output should look like, and then also providing examples of that description so that the model sort of has two things to work with to try to learn how to get the right output here. I'll run this in a second to see how it works, but are there any questions about just what I did here, the techniques, Ainsley?
Why are we not using a
Yeah, the question is that there are other language models that their purpose is just to, they somehow directly take this sort of stuff in as input, and they just directly output in like a different format that's easy to parse and work with these things like Harrison Trump. And if that's the thing that we're doing, we're trying to figure out what these masks are supposed to be. Why are we not using one of those models that's designed directly to like doing this masking stuff? Why are we going through this big like roundabout process of using these generative large language models like ChatGPT, Llama, the Grok API, all this stuff? Why are we doing this? And it's a great sort of question to be asking, making sure that you are always in touch with the big picture of what we're doing here. The answer is that in some sense, we don't really care how good like a model is at predicting these mask tokens. Like our end result is I'm never going to actually like be in a situation where somebody has given me a piece of paper with the one word torn out on it, and I have to figure out like what is the missing paper here and missing word here, and if I can figure it out, then I'm going to make $1 million. That's never going to be a situation that I'm in. The situation that we are in is that somehow previously we built a RAG system in this case, and we want to know whether our RAG system understands certain facts about the world. And so if we were just trying to like find the best possible way to solve this task right here, our RAG system is not the best possible way to solve this task right here. But this task is one way that we can measure how good our RAG system is at certain tasks that are related to the things we care about, but not directly the things we care about. Like a real thing that we care about is if we're having a conversation with our RAG news, is it a good conversation? One way that we can measure if it's a good conversation is it getting things factually correct? And this is our way of understanding, trying to quantify somehow whether our RAG news system is able to get certain things factually correct. Does it have the knowledge that Harris is in fact the Democratic nominee or not? Does it have the knowledge that Trump is the Republican nominee or not? And so this type of benchmark helps us know if it has that knowledge. If it gets these correct, it guarantees that it has that knowledge. It doesn't guarantee that it's like a great conversationalist, but it guarantees that it has that knowledge. So the reason we're not doing a different model that's better for this particular task is because our goal is really to evaluate that RAG news system. And this is one way of doing it. Somewhat roundabout, but a way of evaluating it. Does that answer your question?
Yeah, so the goal here is to then like scale it up to a whole data set of asking refill.
Exactly. So then the question is, after we have this predict function, what do we do with that predict function? Well, in any scikit-learn predictor, that any class that has a predict function that has two arguments like this follows the pattern of a scikit-learn predictor. And now we can use any of the scikit-learn tools to evaluate the quality of this model. So we can use their tools for like measuring accuracy or F1 scores or various different like accuracy measures on this model, and it will tell us like, oh, it got a 50% on this data set, or it got 100% on this data set. But basically, yeah, the data set that we'll be working with has about 300 of these different sentences inside of it that will test the model's understanding of different facts about the election. And we'll be calling this predict function on every one of those sentences, testing to see is the output that we get down here what the correct output should be. And if it is, then adding all of those correct numbers up, and that will be our measure of how good the model knows its facts about the world. Does that answer your question? It was a good question. Other questions about anything so far? Okay, let's come down here and we'll see if our model is actually a little bit better now. I've got to use the up arrow a couple times to get the output of the models here. Now I'll hit enter. And so there's a pretty bad answer right here. I'm ready to answer. Just please provide a standard closed style benchmark question, blah, blah, blah. So that doesn't look good. Let's see if it does it again. Please provide the rest of the input sentence. Okay, so it got it right here 1 out of the 3 times. This one down here, yeah, so it's providing a, here Biden Trump is getting itself confused, both on formatting and the answer. So sometimes it gets it right, sometimes it gets it wrong. Most of the time it looks like it's getting it wrong so far. So you look down here, this last one, it got it right, but the formatting's still a little bit botched. So we still have a ways of work to go here. For when I was testing this out earlier, what I had to do next, there was no amount of prompt engineering that I could do, that I could come up with that would get me the correct answer or that would get me the right formatting on this solution. And so what I had to do was, in order to make this part 1, in order to improve 1 above, so the code above, make it actually better, I say prompt engineering didn't work, not fully at least. I had to change what model I was using. And we haven't talked too much about different models yet at this point, but the Grok API allows you to use a large variety of different models in order and pass your LLM code to those different models. If we come back over here, here's a link that goes to all the different models that the Grok API supports. There are, yeah, so I don't know, there's like 20 or so different models that it supports. The default is, I believe, this Llama 3.1, 8 billion preview, this one right here. This is the default model ID. The 8 billion over here, this is the size of the model, and models that are smaller are cheaper to run. Models that are larger are more expensive to run, but usually better. So the 8 billion model here, this is the smallest of all the Grok models here. They made it their default in their tutorials because it's cheaper for them to have everybody using the default as their default thing, something small. But we can get better results if we go to something bigger. Sort of the first thing to do if you're trying out different models is try something bigger. In this case, large language model world, they're large language models because bigger has proven to be better in basically every case. So I'm going to copy this model string right here, copy that. And instead of using the 3.1 8 billion instant, I will use 3.1 7 billion versatile. There's a bunch of different things you could do in your code to make using a different model like more ergonomic or good software engineering things. But what I am just going to do as a cheap hack right now is change this string right here in my run LLM function so that the default model right here that's being passed in, the default model is that's being passed right in here into the API call into our chat completions crate. Instead of using that default model, I will use this newer model right here. And actually, I'm just now noticing that the model that I was previously using was Llama 3, 8 billion, Llama 3, 8 billion. The new model is Llama 3.1, 70 billion. So it's better in two ways. It's better that it's the next version up. It's trained on different data because of that. So the model versions for everything newer is better, and it's bigger than the previous one. So it should be better in both ways because of that. And now with this better model, hopefully this is still the case, but in all my tests previously, doing something like this, it was now able to, most of the time, get the right format in the outputs over here and the right answers. So do that and do this. Still not working super well. There's one last thing that we do have to change that that I'll change here in a second, that I think I'll get it to work. But before I change it, that one last thing, talk about what that is. Any questions about the different models, why using a better model is going to give you better results or something like that? Yeah. So the question is, do we only change it in the init.py and not other places? And this is the sort of question that has a couple levels of answers to it. The first level of answer is that there is no now ragnews.py. I deleted my ragnews.py and changed it so that it is now called init.py. So there is no other run LLM function anywhere in my code repository where I could possibly change it. The actual code that I was doing when I was messing around with this is that I made this model thing be a parameter that could be passed through, like say the rag function, not just this run LLM. And so in the evaluate function over here, I could specify, try out a bunch of different models, and it would come down here, specify what model I wanted to use rag with, and that would pass it on to the run LLM function. There's no need to do that. Changing it just right here, because the rag will internally call run LLM, will cause it to use this new model. But there are many ways that you could pass this new information of new model information, and they all have different trade-offs about simplicity versus simplicity of implementation versus simplicity of trying out different models to see which one's better. But yeah, and the change that I did, all you had to do is make this one change, and it now uses that new model. One of the things that sort of help verifies that it is in fact using the new model, even though the answers maybe aren't perfect down here, is that the answers here are very different than they were before. It's always talking about, to answer this question accurately, I need to know more things, blah, blah, blah. But no information provided about the Democratic nominees. And so it seems like it's understanding the question maybe a little bit better, but it doesn't have access to the information down here. And I'll say in a second why that's the case. Yeah, Albert.
I think I just searched up Grok has like a JSON mode. Would that work better?
Question is, a lot of models, a lot of APIs have different types of output that can try to format things in JSON or something. The answer is we'll talk about some of those things next week. Don't try to do that for this assignment. You'll probably go down the wrong path. So here, the reason why this is not working correctly is because recall that in my ragnews.rag function, the text prompt, whatever I pass into this rag function, I'm extracting keywords about the text prompt here. So I'm extracting probably 10 is what you had it suggest, keywords about the text prompt here. And this text prompt is not like the thing that I want to extract good keywords from, like this part right here. This is the only part that I actually want to extract keywords from. Instead, it is extracting keywords also from like all of these instructions up here. And so the keywords are going to be looking like fancier and sentence and masked and close. And if I read all the outputs to these predictions down here, we can see that, oh, to answer this question accurately, I need to know what the current Democratic nominee is. So we can see that like somehow it's not actually getting the information about who the current Democratic nominee is. And that's because the keywords are not extracting on this stuff, or they are extracting keywords from this stuff up here, rather than keywords only from this stuff down here. So what I'm going to do is I'm going to have to modify my RAG function down here so that there's the text part that's being input, but also the keywords text. Say that we'll make this a last parameter. I'll be a little bit fancy with my Python here. I'll make this a default argument of none. And the very first thing I'll do in my function over here is if keywords text is none, then keywords text equals text. And so basically trying to be compatible with all the stuff that I've previously done, where my RAG function assumed that there was no keywords text, wasn't passing anything in for this argument. So I'm going to make my function, I want it to stay backwards compatible. So when I add this new argument over here, I'm going to do it in a way that it'll be backwards compatible with everything. But the meaning of this argument right here is that if it's provided, then this is the only thing that we actually extract the keywords from. We only extract keywords from this and not this. This text right here will be the prompt that I actually pass in to the model, but this will be the thing that I get the keywords from. So the keywords text, if it's not specified, it'll just be the regular text. But if it is specified, then we will use the keywords text itself. And now coming back to my evaluate function, I can say that the keywords text is the masked text like that, or maybe the masked text, yeah, we'll just do the masked text for now, like that. And now it should be extracting the keywords just from this part and not from everything else. Verify that, come down here, up arrow, rerun this, model is not defined. Where?
In init.py, you spelled keyword wrong.
Where did I spell it wrong? Keyrods, keywords. To answer this question, I need information about the please provide related news articles. So still not getting those related news articles somehow. Let's come down here. Another good debugging strategy is I need to actually, a good debugging tool, anytime you're using LLMs, actually look at what the system and the user prompts are right here. You see that I'm currently using this logging.info function, which will send this information about the current system and the current user prompt to what's called this logging package in Python. In order to view those logs, in order to view this output up here, I need to change what's called the log level of my program down here in the this set of lines right here that's at the bottom of the ragnews.py file, what it used to be, current init.py file, is part of the code that I initially provided for you. This sets what the current log level is. I'm going to copy this over into my evaluate.py so that I can view those things. A simpler thing to do maybe is, so on these lines up here, if you change logging.info to print, then it would always print to the screen. But it's nice to be able to sometimes print to the screen and sometimes not. But you could change this to print, or you can do this more complicated thing of this thing down here and saying level equals logging.info, and it should print out the actual prompts that are being sent now. And so now I can look at this and see the actual prompts that are being sent over here. So we see the input output pairs come up, check out the news articles. I don't even see any news articles being included in here. So somehow my RAG function is not including news articles. verify that the RAG function is including news articles. This articles list from db.find articles. I will do a quick assert length of articles is greater than 0. So assert is going to panic throw an error if this this condition over here is not met. I'll just verify that that's what happens. If I do assert false, we'll see that this is guaranteed to throw an error on line 147 because the thing inside this parenthesis is false, so it does not evaluate to true. And so we get this assertion error right here thrown on line 147 of the init file right here. And so line 147 right here, change that to this, it's called an invariant that I expect the articles here list to maintain this invariant right here. And so a good debugging practice, anytime there's some sort of invariant in your code that the code always must maintain, like the number of articles is greater than 0, you can have an assert in your code. And if that invariant is maintained, nothing changes, nothing bad will happen. But if it is not maintained, then you will get an error, which will help you in your debugging. And so I am getting an insertion error right here about my keywords. Like I'm not able to find articles about those keywords. So if I go to my find articles, maybe I accidentally don't have the implementation here still. Oh, I do have the implementation here. Yeah, so this is the problem here, that I did my db equals ragnews.articledb, but if I don't provide a database, then it's it uses an empty database. So I actually have to specify over here that what we call the database name ragnews.db, ragnews.db, like that. And now rerun this, and we're seeing the output there. But it is actually getting the format here, or it's getting the answer correct. The format's not super correct, and occasionally getting that assertion error. Looks like it's do more often. Well, it's doing better than it was before, but it's still not perfect about things. So, but it's a little bit better than it was before. But so there's more fiddling around. At high level, what needs to happen next in order for me to finish this assignment, there's more fiddling around with the prompt up here, and maybe better input-output examples or a better explanation up here of what the prompt is supposed to be doing in order to get these better results down here. Maybe, yeah, since there's just a minute or two left in class, after you have, so this bullet point 3 right here is talking about the different hyperparameters to tweak to change those results. But your goal is this particular very longly named file. This has the data points that are inside of it. And your goal is to get at least 70% accuracy on this file right here. So you'll have to actually implement a for loop that calls that predict function for each line in this file, and then checks to see if it's correct or not, and actually make sure that your predict function is doing better than my live coded predict function is up here. You do that, finish the predict function, finish this for loop that calls predict on every line in the file, and that's it for the assignment. Questions about what to do for the assignment? Max?
I had a question before about when you were saying how it was getting like an empty database. How was it able to like return errors that was kind of before? Like where was that hallucinating from?
Oh yeah, that's a good question. That sometimes it seemed like it did get the right answer here. So when I didn't have any news articles, how did it do that? Just yeah.
It was an example.
Oh, that's a good point. That my examples up here, the things that I was actually testing on right here, are hard-coded examples up here. So it would have gotten this information from the input-output example up here. Yeah. Yeah. So that's a good point. And like the hard part about working with these LLMs, one of the hard parts is that there are so many different moving parts going on here, not just the prompt engineering, but just other random Python things like making sure your database is actually connecting to the database. And so the big picture reason why I'm doing this live coding. I didn't intend to have these particular errors come up before the class, but they came up, so that you can see what are some of the procedures that I use as I go through, find these unexpected errors and debugging tools. So things like this logging library to print output selectively when it's useful is a first line of defense, like that I'm always using when I'm coding. And secondly, these asserts to check whether these invariants are being maintained or not maintained in my code. We're a little bit over time, so we will end here. There's still a lot to do for the homework assignment. So again, certainly not going to be offended if you're not able to complete it by the nominal deadline of Sunday. Have office hours tomorrow, happy to chat after class right now about things, or in class on Monday about more things if you, after working on this for a bit, have more questions. But that's it for today. Apologize for going over time, and so have a good weekend.